Very, very important section. You can say, oh, we say that every time. Well, everybody thinks the first chapter of a book is sometimes the easiest, but a lot of times it's also the most important. Adjacent. One of these are adjacent to adjacent angles. Only one of those four are adjacent angles. Does anybody know which one? You know what adjacent means?
Right next to each other.
Yeah, or beside. Okay? Just gonna have to deal with that, guys. Anybody want to venture a guess? Which one? This one? Okay. These are beside, but no, they are not adjacent. And I haven't told you the definition, so it's okay to be wrong. I could see why you'd say it because they're kind of beside each other, right? Yeah, no doubt. What about this one? Do you guys think this one? No is right. How about this one? So which one is it? In geometry, yes, adjacent means beside, but in geometry, they have to have a common vertex and common vertex and common side. So, as the word adjacent meaning beside does help you. Okay. As the word being beside does help you, kind of leads you in the right direction, it doesn't tell you everything. Okay? Basically what I've put here is all the possible things that could get that you might think beside goes with but doesn't quite work. Make sense? Okay. The next two are super, 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 super important. You will use them over and over and over again. First one is called a linear pair. Next one is vertical angles. Okay. First, let's focus on linear pair. Always try to use a little wordplay to help you understand what does that word mean. Line. Okay. First of all, these two right here are not a linear pair. The reason these two angles right here, 1 and 2, are not a linear pair is because they don't create a when combined. So this is an example of a linear pair. Everyone watch. Don't write just yet. There's an angle. Would everyone agree with that? The angle that would form a linear pair with it would be the one that I would come over here and use my straight edge, and I would simply just complete the line. Because together, angles 1 and angle 2 here, what do they create when put together? They create a line. So these are a linear pair. What do we know about the measure of a straight line? The angle. It's what? That's what's so important. You can look at a picture. This is one of the things you can look at a picture and know. If they make a straight line, then you know here that the measure of angle 1 plus the measure of angle 2 has to equal what? 180 degrees. You say, oh, that's not that hard, that's not that big. It is a big deal because you're going to see it in a lot of pictures from the first thing you do to the last thing you do in this class. From this point on, if you see a straight line and you see two angles making that straight line or three angles making that straight line, you're expected to understand that all of those added together have to equal, 180. I'm pointing at a number because I want you to say it. I want to hear you say it. So 180 degrees. When you have a straight line, what's the measure of that angle? 180. There you go. So no matter how, everybody's got this down, right? Just watch. Are those two a linear pair?
No.
Why not?
It's an angle, but it ain't 180.
But did I make a straight line?
Yeah.
Did those two angles create a straight line?
Yeah.
Guess what? Linear pair. What about that one?
Yeah.
Linear pair. What about that one?
Yeah.
What about that one? What about that one? You don't know. Yeah, it looks like I tried to make them 90 and 90, but this might be 89.5 and this might be 90.5, right? Well, what's the moral of the story? What am I always drawing first when I make these? Linear pair? All of these are linear pairs except for that one, because together the two angles didn't make a. What about this? I could get real complicated. They're not a linear pair, but what do all these angles together make? So what could I say? The measure of angle 1 plus measure of angle plus what? Measure, say measure of angle 3 plus what? What's all that can equal? Why? Because on the picture they all together make a straight line. There's really only one type of line and they're all straight, but I still like saying the word straight, so we see that that's crooked, right? So those can't add to 180. Any questions on that? Pretty easy concept, right? But you'd be amazed. You'll have these very complicated pictures. Or not complicated, but pictures with a bunch of different, you know. For instance, look at something like this. I guess whoever had this book wrote in a little. I'm not sure what. I'm going to erase this. But this is kind of a pretty crazy looking picture, isn't it? This is from your assignment. There's a lot going on there, isn't there? But if you look at the straight lines, what do I know here to here is? 180. What about here to here? How about here to here? How about here to here? How about here to here? A lot of things you could say add to 180 in there, aren't there? So you can see how this is an important thing and something that can be very useful. They won't tell you that, hey, these two are a linear pair. They expect you to look at this picture and say, I know that those two right now have to add to 180. If I know if this one's 30, what's that one going to be? 50. Because together they make a straight line. So they have to add to 180 degrees because that's half of a circle, right? What's this? These two, this one right here, what's it got to be? 90, because this one's 90, so whatever's left to 180 is what? 90. Now I don't know particularly how these two are split up just yet, right? But I know that those two added together have to equal what? 90. And that's the other part about this section. For some reason, people have no problem saying that the two smaller parts equal the whole thing when it's a straight line. That this, call it this plus this equals the whole thing, right? Everyone agree? Is that any different for an angle? This smaller part plus this smaller part has to equal the what? The whole thing, right? It's the angle addition postulate. And doesn't that make sense? If the whole thing was 80 and this one was 30, what's this one got to be? This angle's 30. This whole thing right here was 80. What's this part? Huh? 50. Because this plus this has to equal the what? The whole thing, right? Okay. Just wanted to talk about that. Okay, back to this. So we okay on linear pair? Made my point. It's very important. Vertical lines, just as important. It is another thing that you will be expected to look at a picture. And this one's probably as important or more. Anytime two lines intersect, we'll just say the opposite angles are always, what does that mean? What does that mean? Congruent. These angles are called vertical angles. So what am I saying here? This is angle 1, this is angle 2, this is angle, 4 angles are always going to be created when two lines intersect, aren't they? Which ones are the opposite angles? Give me an example of opposite angles here. 1 and 3. So I'm saying that any time two lines intersect, the opposite angles are what? Congruent. Angle 1 would be congruent to angle 3. Are there any other opposite angles? 2 and 4 have to be what? Now notice I use two lines because they aren't necessarily, the adjacent ones aren't. So angle 2 is congruent to angle what? Anytime you look at a picture, you see two lines intersecting, what do you know? The opposite angles are, period. I just drew another two. What do I know? Boom, 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 boom. No matter how I draw them, opposite angles are what? Don't draw this. No matter how narrow I draw them, right? See how it's kind of a common thing? I just do it over and over again and it stays the same, doesn't it? These kind of relate to each other because what about 1 and 2? What do we know they add to? But 1 and 3 are congruent. 2 and 4 congruent. What about 4 and 3? What do they add to? 2 and 3. 1 and 4. But the opposite ones are the same. Make sense? Once again, you'll use that over and over and over again. Back to the complicated picture. Do you see any vertical angles inside of this picture? There are some, aren't there? Look at this vertex F. Are these two lines intersecting? So I know that that is congruent to what? That and that is congruent to that. What about right here? Are these at G? Is G an intersection of two lines? So 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. Right? There's some there that you know were congruent, right? Just by looking at the picture. Now, what about right here? Yeah, they didn't extend this line, did they? So I really don't have any vertical angles here. Same thing here, same thing here, same thing here. They didn't extend it, but here I make the X, right? Whether it's a fat X or a skinny X, right? And what do I mean by fat X? Like that or like what? Agreed? Just you find the X somewhere, you know that you have what? Vertical angles and that they are congruent. I can't stress enough how much you'll use that over and over and over again. Now we'll go to some terms that you've used before that really you just got to apply these facts. Complementary angles. Supplementary angles. And we'll say perpendicular lines. The sign for perpendicular is that right there. That upside down T. If I wanted to say L is perpendicular to M, I can use that instead of perpendicular, and I'll draw a picture for that. These two go together more than the others two. Do you guys remember what complementary angles are? Angles that add to 90 degrees. So the measure of angle 1 plus the measure of angle 2 would equal what? 90 degrees. That's complementary. Supplementary, the thing you will deal with more. And this is more kind of an end of instruction or ACT type definition that you just got to know. Okay? Angles that add to, you know the difference? 180 degrees. Perpendicular lines, two lines that intersect to form right angles, 90 degrees. And they intersect to form four right angles, don't they? This is L and this is M. L is perpendicular to M. What do you think the complement of a 30-degree angle is? I know I haven't told you what complement means, but I want you to use common sense. If you had forgotten all about that, but you remembered this, and you said, hey, what's the complement of a 30-degree angle? What would make sense? Huh? A 60-degree angle. Why is that? Why do you think a complement of an angle is, of a 30-degree angle, is a 60-degree angle? Because they add to 90 degrees. What is, but does the word help you there? Complement. Oh, what's the only thing I'm leaving off there? Uri. Complement, Uri. So the complement is always the angle. So what's the complement of a 40-degree angle? Anybody? No. Complement of a 40-degree angle. What does complementary mean? It means that they add to 90. So the complement of a 40-degree angle would be a 50-degree angle, because 40 plus 50 is. So what's the complement of a 70-degree angle? 20-degree angle. What's the complement of a 5-degree angle? 85-degree angle. You get what I'm saying? It's a play on words. What is the supplement of a 100-degree angle? Ah, see, supplement has to do with what? Supplementary. So, what's the supplement to a 90-degree angle? 90. Okay. Okay, that's all the information from this section. Let's get out our little red books and see what see if we can apply this information to some examples. Headphones out, Junior. No headphones during notes. I get really, really, really cranky when that happens. Wow. Two acute vertical angles. I just got to look over here and find vertical angles. So, what is the deal with vertical angles? It's where what? Two lines, the opposite angles when two lines do what? Intersect. So, it needs to make an X, right? Two acute vertical angles. So, they are going to ask me to look at it. So, acute means what? Less than 90. Well, really, on this picture, I only have two real lines that create vertical angles, right? And in my mind, I almost need to kind of erase that, don't I? Would you guys agree with that? And if you'll and sometimes if you'll just kind of do that in your mind, or even do it lightly with your pencil so you can erase it, it'll help you. So, which one? This is a vertical angle, this is a vertical angle, this is a vertical angle, this is a vertical angle. Which one is acute, do you think? You got to name it the hard way. Angle what? Huh? Come on, people, wake up. I can't say angle F. Why would we say angle F? What angle would angle F be? Or angle G? How are you supposed to name an angle? FKG? You name it how you would what? Draw it, correct? So angle FKG and angle what? EKH. And that accurately describes the angles, doesn't it? The biggest problem I think a lot of people have, and it's okay for you guys to make that mistake there, when you're doing your homework, say to yourself, does that really describe what I'm talking about? You know, definitively. I think sometimes we get frustrated because we don't remember exactly how to do it and we just guess. Hey, it's okay to look back at the previous assignment and reinforce or look at some examples. That's the biggest thing that you guys need to do, is start looking at examples. Everyone sit up. Make sure you're not sleeping. Where's your red book at? That's what we're working in right now. So get it out, turn it to this page. Page 9. Name two obtuse vertical angles. Well, these were the two acute ones, right? What are the obtuse ones? These two, right? So how would I name those? Angle EKF and angle what? You guys get the point I was making earlier, that if you don't understand the language, you couldn't even do the next section's problem if you didn't know how to name an angle, could you? And it's like you guys could probably point to the angle you wanted to talk about, right? You just couldn't write it down. So that's why it's so important that we get angle, or section 4, that we understand, because everybody hates having to do that in their head. But you know what? You're going to have to do things in life you don't want to do. or that aren't, you know, that aren't fun to do. Is that the right way to describe that? Name a linear pair. What is a linear pair? If you don't remember, go back to your notes. All you have to do is look at the picture. Look at all these pictures. It's the one that creates a two angles that create a what? Straight line. Pair means two. So when they say linear pair, they're not just saying a bunch of angles that add to 180. They say what? Two that are beside each other, adjacent, and add to 180 and make a straight line. So we've got different choices here, don't we? What line do you want to deal with here? Tell me the line. H2, F, you want to deal with this one? So that would mean this angle and what? That angle. Now I just need to name them, and if I don't know how to name them, I'm in trouble. So, angle what? H, K, E. Can't go this way because that's actually a different angle. See what I mean? If I get my pencil down and went H to E to K, I draw a different angle. So just, and if you, like I said, if you're curious whether you're naming it correctly, simply put it down there. H. If I want to draw this angle, what's the next point I'd go to? And then where I'd go. And what's the other linear pair? I could have even gone to FKE. Yeah. Name two acute adjacent angles. Now there are other answers to the linear pair, but there's really only one here. Acute means they what? They're less than. And adjacent means they share a common what? Vertex and side. Which one would that be? This right here is 90 degrees. Wouldn't the two that make up a 90-degree angle have to be less than 90? So they're acute, and do they share a vertex and side? Here are our two angles. Angle what? J and angle. Nope. GKF. Because JKF would be the 90-degree angle. Name two complementary angles. That's two angles that add to 90 degrees. Aren't they the exact same ones we just did? Doesn't this angle and this angle have to add to 90 degrees? Right, because that's a right angle sign, and this the two smaller parts have to equal the whole thing. Name an angle supplementary to FKG. FKG. So they want to know one that's supplementary to that angle. It has to be the one that creates a what kind of line? Straight line. So what angle would it be? This one from here to what? Here. So how would I name that angle? Find the measures of an angle and its complement if one angle measures 24 degrees more than the other. This is like a mixture problem or whatever. You've got one angle that's X, right? What's the other angle? X plus what? It's 24 more than the other one, right? So I can call it X plus 24, right? What are they supposed to be? Complementary. So when added together, what do they have to equal? There's your equation. So it'd be 2x plus 24 is equal to 90. Subtract 24. Subtract 24. 2x is equal to what? 66. Divide by 2. X is equal to 33. So if it's 33, what's the other angle? It's complement. It's 24 more than that one. So 33 plus 24 would equal what? And don't those two add to 90? Guys, you guys gotta wake up. Hey, I understand. It's tough to get back in school shape. But you guys gotta wake up. Here's what I want to do. That's enough to get you started. I want to answer questions tomorrow. You have 16 minutes.